Hello students, how are you all? I hope you all are keeping well. So, I'm Priyanka Singh, your science teacher. Today I'm here to start with the chapter number 11 and unit 4. Unit 4 is moving things, people and ideas. And the name of the chapter is force and pressure. So, how many times do you push or pull something every day? Pushes and pulls are forces. Look at the pictures. The man is pulling the door of the car to open it. The boy is kicking the football. This ball is stopped by the goalkeeper. In pulling the door and in kicking or stopping the football, forces used. Forces used to push and pull anything. We have to apply force on the pedals of a bicycle to make it move and also have to apply force on the breakers to stop it. So students, these are some pictures which are showing the forces and pressure, like opening the car door, kicking the football, goalkeeper. You may push the door with great force. If the door still does not open, you may call your brother or father or mother to help you. All of you apply force to push the door open. Thus, you will have to push or pull some of the items using whatever force is necessary. Force. Force is defined as the push or pull on an object. When things are moved changing their position, force plays a very important role. Some common applications of force in our everyday life are force applied to open or close the door, lifting of your school bag or any kind of luggage, kicking a football, animals pulling a cart, all objects being attracted towards the earth. Pull works in the examples 2, 4, 5 while push in examples 1 and 3. So, force is that pull or push which can change the state of motion or rest of an object. It can change the shape, size or dimension of an object. Effects of force. Force can bring about a number of changes. Some of the effects of force are given here. Force can make a stationary body at rest, into motion. When force is applied on a body at rest, it begins to move. A football kept on the ground starts moving on being kicked. Boxing bags start oscillating on being punched. So, these are some pictures. The picture is showing boxer beating an oscillating boxing bag. And in the second picture, players kicking football. Force can change the speed of an object which is in motion. A car slows down when brakes are being applied and then comes to rest. A moving ball stops and then comes to rest. A moving ball stops when being stopped by the leg. A moving swing slows down its speeds when somebody holds its rope. In all these examples, what we observe is that the speed of the moving object is being altered on the application of force. So students, these are the picture. This picture is showing motion and force, like a car slowed down when brakes are applied, and another picture is showing a moving swing. Force can change the direction of a moving body. When a bowler bowls, the ball moves in forward direction. The same ball on being hit by the batsman changes its direction and moves in some other direction. So, this is the picture showing force changing the direction. A toy car on striking the wall starts moving in some other direction. Thus, it is clear from the examples that force is capable of changing the direction of a moving body. Force can change the shape of an object. If an inflated balloon is pressed between the palms, clay is rolled between palms. Floor dough is rolled with a rolling pin. We see all these objects change their shape. Thus, force has the capacity to change the shape of an object. So, this picture is showing how the force changes the shape. How is a force caused? Interaction of two bodies. Look at the following pictures. The A picture is showing a fun ride, and the B picture is showing dog pulling its leash, and the C picture is showing stepping out of a boat. Consider the case of the fun ride where the seats are attached through the fixed hooks of the support. When the ride is given a movement, the two hooks pull in the opposite direction and support each other. Similarly, in the other example shown above, it is difficult to decide which of the two objects is pulling or pushing the other. As you can see, the dog is being pulled and also it pulling the leash. Also, the boy pushes the boat during stepping out, and as a result, the boat pushes the ball out. In all these examples, the two objects are mutually interacting, thereby applying force on each other. In the same manner, when a ball is hit on a wall, the pull applies a force on the wall, and as a result, the wall applies a force on the ball and the ball bounces back. So, thus we can conclude that to apply a force, a minimum of two bodies must interact with each other. Let us look at some more examples to understand this fact clearly. When a friend hits you on your arm with his hand, it is an interaction between his hand and your arm. A force is applied on with, therefore, both your arm and his hand ache. An extra mile. To be able to walk, we apply force on the ground through our soles. As a result, the ground pushes applies a force as in the opposite direction. Types of forces. As we have already seen that when force acts on an object, it experiences it is as a push or pull. Thus, there is a necessary interaction between the objects for the force to act. The moment this interaction ceases, the force also ceases. This interaction between the object may be contact force, non-contact force or action at a distant force. Contact force. When force acts between two objects and when they are in physical contact with each other, the force is said to be contact force. For example, when a footballer kicks the ball with his leg, the ball and the leg are in contact with each other. Thus, it is a contact force. Contact force may further be classified into muscular force, frictional force, and mechanical force. Muscular force. The force applied by our muscles in doing any activity is termed as muscular force. Pushing the door, lifting up a heavy box, opening the table drawer all require muscular force. Muscular force is also referred to as a biological force. At times, it is so happen that human's muscular force is not sufficient to complete a task. In that case, we take help of other living things like horses, bullocks, etc. There are instances when animal force is also insufficient. Then we take help from non-living things like pulley or other simple machines. So these are the pictures showing muscular force. Frictional force. Force of friction acts on the moving object and its direction is opposite to the direction of the motion. The force of friction arises because of contact between surfaces. You will learn more about it in the next chapter, friction. Mechanical force. In some cases, machines are used to generate force. These machines utilize the human muscular force to generate force. The force so generated is called mechanical force. In simple terms, mechanical force is the force generated by machines. Some examples are forces generated by screwdriver, stapler, rail engine, etc. So these are the two examples of mechanical force. Non-contact force. This type of force arises when objects are not in physical contact with each other. The force acts on the objects from a distance. Some non-contact forces are gravitational force, magnetic force, electrostatic force. Gravitational force. The force exerted by the earth on all objects is called gravitational force. It is by this force that all bodies are attracted towards the earth. So, this is the picture of free falling under gravity. This force acts as a distance force as all objects are not necessarily in contact with the earth. The gravitational force exerted by the earth opposes the upward movement of an object. Due to this, the speed of the object decreases and becomes zero. The force of the earth, which is still acting on it, pulls the body and it falls down. When a stone is tied to a rubber band and held in the hand in such a way that it hangs freely, the rubber band stretches and we say that the weight of the stone is more. The weight of an object is thus the measure of the force with which the object is pulled towards it. Weight is equals to mass into gravity. So now there is an activity, and the aim of this activity is to show the effect of gravitational force on the object of different weights. Material required: a spring balance, a small polythene bag, one big and one small pieces of stone, pen and notebook. Procedure: take the spring balance and set its pointer at 0 mark. Now hang the polythene bags in the hook of the spring balance and place smaller piece of the stone in it. Note down the reading shown by the spring balance. Then remove the smaller piece from the polythene bag and place the bigger piece of stone in it. Again, note down the reading of the spring balance. What do you observe? Observation: the spring balance shows greater reading in case of a bigger piece of stone. Conclusion: the earth pulls the bigger piece of stone with large gravitational force as compared to the smaller piece. When we weigh an object using a spring balance, we actually measure the earth's gravitational force acting on the object. Note: if we weigh the same object on the surface of the moon using a spring balance, we will find that its weight is less than what it weighs on the earth. It is because the moon has a smaller force of gravity as compared to that of the earth. The gravity on the moon is 1/6 of the earth's gravity. Magnetic force. Magnetic force refers to the force exerted by a magnet on a magnetic substance. This force acts on an object from a distance. However, when the force has acted upon the object, they come in physical contact with each. Magnetic force finds its application in a number of areas like separating scrap iron from a heap of garbage. This is the picture showing magnetic force. So now there is another activity for you children. And this activity is to put some iron nails on a sheet of paper. After that, you have to bring a small magnet near these iron nails. You will see that iron nails are pulled towards the magnet, even when they are little distance away from it. This shows that magnetic force can act from a distance. After combing your hair, when you bring the comb close to a bit of paper, they are attracted towards it. This force is an example of action at a distance force and is called electrostatic force. We can understand it with the help of another example. Run and comb through your hair again. This time, hold it near a thin stream of water from a tap. The streaming water will move towards the comb. Electrostatic force is useful in controlling pollution by separating solid pollutant particles from the smoke given out from factories. So, these are the two pictures showing electrostatic force. The first one is comb attracting bits of paper and the second one is comb attracts tap water. Now, another activity is take a plastic comb and rub it on your dry hair for about a minute. Then bring the rub comb near the tiny pieces of paper. You will notice that pieces of paper are attracted towards the comb due to a force called electrostatic force. Let us know where else in your daily life you can experience the presence of electrostatic force. You might have noticed that when your mother empties a poly bag of pulses into a container, some of the pulse grains get stuck to the polythene and do not fall in the container. This is because when the grains slip out from the poly pack, they get rubbed and charged. Both the grains and the polythene are stuck together due to the attraction between the opposite charges. If you stand near the screen of working television with synthetic clothes on you, the clothes are attracted by the television screen. This is because a working television screen is negatively charged. The negative charge of the screen attracts the neutral clothes towards it. Objects having no charge on them are called neutral. A charged object, either negative or positive, attracts other neutral objects. Spring balance. Spring balance is a device that measures force. It uses the principle that greater the force, the greater is extension that force produces on a coiled spring. It consists of a coiled spring with a pointer attached to it. As the spring stretched, the pointer moves on a graduated scale. The reading on a scale gives the magnitude of a force. Pressure. As we have already seen, force has a number of effects. They depend mainly on two factors: the amount of force applied and the area on which the force is applied. The physical quantity that relates the force acting on an object and the area on which it acts is called pressure. Hence, pressure is defined as the force acting per unit area of an object. Pressure is equals to force divided by area. Therefore, unit is equals to Newton divided by meter into meter is equals to N, that is Newton, divided by meter square. The unit of pressure is Newton per meter square in SI system. This unit is also called Pascal, that is Pa. After the French scientist Blaise Pascal, practical unit of pressure is bar, which is equal to 1000 Pascal. Applications of pressure. Pressure finds various applications in everyday life. Knife has a sharp blade for cutting. The edge which is sharp has less area. This decreased area increases the pressure and the things are cut easily. Nails and needles have a pointed tip to decrease the area of contact so that for a given force the pressure exerted is more. So these are the pictures showing examples of application of pressure. So buses and trucks have double wheels at their rear to increase their area of contact so that pressure exerted on the ground is less. High and tall buildings have a broad foundation so that their pressure is less so as to prevent them from sinking. Heavy animals like elephants have broad feet to decrease the pressure exerted by them on the ground while they walk. Army tanks have caterpillar wheels to increase the area and thereby exert less pressure on the ground in the battlefields. Pressure exerted by liquids. Pressure is exerted by liquids also. The pressure at the bottom of the sea is very high. It is for this reason that deep sea divers wear a special suit to prevent their bodies from getting crushed. Liquid pressure is measured using a manometer. So students, there is another activity, and this activity is to show that liquid exert pressure. Take a glass tube open at both ends. Tie a balloon on the lower end and pour water through the other end. We observe that the balloon starts bulging. This is because the water is poured in the tube exerts pressure on the balloon, which is visible as a bulge in the balloon. Atmospheric pressure. Just like liquids and solid, gases also exert pressure. The blanket of air Around us, it's called atmosphere, and pressure exerted by it is called atmospheric pressure. The atmospheric pressure is about 10 raised to the power 5 Newton per meter square at sea level and is called normal pressure or standard pressure. We do not feel this pressure under normal conditions, as this pressure is counterbalanced by the pressure of the blood running in our blood vessels. This pressure is called blood pressure. On higher altitude, the atmospheric pressure reduces. However, the blood pressure remains the same. It is for this reason that our blood may start flowing out through the nose and problem of nose bleeding starts. Fountain pens also start leaking at higher altitudes. Atmospheric pressure is measured using a barometer. So, there is an activity, and this activity is to show that gases exert pressure. Take an empty metallic can. Heat it over a gas stove. All the gases present in it comes out. Tighten the lid and leave the can to cool down. What do we observe? The can gets crumpled up. The reason being the gases inside the can was exerting pressure on the inside. When the gases escape out, the atmospheric pressure pushes the wall of the can inside and it gets crumpled. Now, it is another activity with this, and the aim of this activity is to show that pressure exerted by a liquid at the same height is same in all directions. Material required are paper glass, pin and water. Procedure: take the paper glass and make 3 small holes on its side with the help of a pin. Remember, all the holes should be at the same height from the base of the glass. Fill the glass with water. Observe the water coming out from the holes. Pressure exerted by a liquid at different height. The pressure exerted by a liquid at different heights is also different. So now there is an activity, and the aim of activity is to show that pressure exerted by liquids at different heights is different. Material required are paper beaker, pin and water. Procedure: take the paper beaker and fill it completely with water. Make 3 holes using a pen. Along the height of a glass, one near the bottom, the other near the top, and the third is middle of the beaker. Observe the water coming out from these 3 holes. Observation: the water stream from the topmost hole falls nearest the base of the beaker. The steam from the central hole falls a little ahead, and the stream from the holes near the bottom of the beaker falls the farthest. Conclusion: this shows that pressure in liquid is different at different heights. The pressure due to liquids depend on the depth of the liquid. That is, the more the depth, the higher is the pressure. Measuring liquid pressure. The pressure in liquid is measured by using a pressure gauge. A manometer is another instrument which is the simplest form of pressure gauge. It actually measures the pressure difference at different depth in a liquid. So, activity, and the aim of this activity is to make a manometer. So, see how we can make a manometer at home. Material required: an iron stand, a U-tube of glass, a funnel, a rubber tube, a balloon, a thread, a bucket, water and color. Now the procedure. Fix the U-tube in an iron stand as shown in the figure. Fill it half with colored water. Now fix a rubber tube at the stem of funnel. Stretch a balloon on the mouth of funnel and tie it with the thread. Now fix the free end of rubber tube with the one end of U-tube and mark the level of colored water in it. The manometer is ready. The manometer is ready to use. Working of manometer: fill a bucket with water and slowly lower the funnel into the water. When the funnel goes deeper into the water, the difference between the levels of colored water in the two arms of U-tube increases, and when funnel comes towards the surface of water, the difference between the levels of colored water reduces. This difference between the levels of colored water in the two arms of U-tube is measure of pressure exerted by water. Pressure in gases. Gases also exert pressure. They exert pressure in all the directions. What happens when a tire of your bicycle gets punctured? Have you ever seen a mechanic repairing a punctured tire? What is filled into a repaired tire or tube before putting it back to your bicycle? Also, you might have blown a balloon. What makes the balloon grow in size? It is the air, that is, mixture of gases. On repair, the hole created due to the puncture is patched up and the air is filled in it before putting it back to the bicycle. You also know that the tube of the tire blows up when air is filled with air. Here also the pressure due to air is working. SI unit of pressure. In SI system, the unit of force is Newton and unit of area is square meter, meter square, as P is equals to F/A. The unit pressure is Newton per square meter. This unit is also known as Pascal. That is, 1 Pascal is equals to 1 Newton per meter square. It is named after a French scientist, Blaise Pascal. Let us practice some problems to have a clear understanding of pressure. Students, these are the examples of pressure. So, go through these examples thoroughly and practice in your copy. Now, the example 1, example 2, example 3. It's time for Reader's Digest. Force is seen as a push or a pull. Force acts only when the object is tracked. Force can make a stationary body into motion. Pressure is equals to force divided by area. Pressure is exerted by solids, liquids and gases. Atmospheric pressure is measured using a barometer. So students, it's time to take your leave. We'll meet in the next class and bye.